Our planet is warming, ice caps are melting, sea levels are rising, and extreme weather events are becoming more frequent. This is climate change, and it's happening now. We are already witnessing its devastating effects around the globe, from wildfires raging across continents to unprecedented heat waves scorching cities. The urgency of the situation cannot be overstated. The primary culprit of this global crisis is the excessive release of greenhouse gases, primarily carbon dioxide, into the atmosphere. These gases trap heat from the sun, causing a gradual warming of the Earth's surface and atmosphere. Human activities, particularly the burning of fossil fuels for energy, have significantly amplified this natural process, pushing our planet to the brink. Coastal communities face an existential threat from rising sea levels, with millions at risk of displacement due to flooding and erosion. Changes in precipitation patterns will disrupt agricultural practices, leading to food shortages and economic instability. The delicate balance of ecosystems will be thrown into disarray, threatening biodiversity and the intricate web of life on Earth. Amidst the dire warnings and the escalating climate crisis, a glimmer of hope emerges from the world of science. A groundbreaking technology, dubbed Solar Geoengineering, promises a potential solution to reverse the devastating effects of global warming. This innovative approach aims to mitigate the impacts of climate change by reflecting a small portion of sunlight away from the Earth. Imagine a shield, strategically positioned in space or our atmosphere, subtly deflecting the sun's rays to cool our overheating planet. One method involves releasing tiny reflective particles, such as sulfur dioxide, into the stratosphere. These particles would act like miniature mirrors, scattering sunlight back into space and reducing the amount of solar radiation reaching the Earth's surface. Another proposed technique involves brightening marine clouds. By spraying seawater into the lower atmosphere, scientists believe they can increase the reflectivity of clouds, enhancing their ability to reflect sunlight. While still in its early stages of development, solar geoengineering presents a compelling solution to combat global warming. However, as with any new technology, thorough research, careful consideration of potential risks, and global collaboration are crucial before its large-scale deployment. The understanding of climate change and its anthropogenic roots is not new. As early as the late 19th century, scientists began to unravel the intricate relationship between carbon dioxide emissions and the Earth's temperature. The groundbreaking work of Swedish scientist Svante Arrhenius in 1896 laid the foundation for our current understanding of the greenhouse effect. However, it wasn't until the latter half of the 20th century that the scientific community began to raise serious concerns about the potential consequences of unchecked greenhouse gas emissions. The landmark Intergovernmental Panel on Climate Change, IPCC, was established in 1988, tasked with providing policymakers with regular assessments of the scientific basis of climate change, its impacts, and future risks. Over the decades, numerous efforts have been undertaken to mitigate climate change and reduce our reliance on fossil fuels. International agreements, such as the Kyoto Protocol and the Paris Agreement, have sought to establish legally binding commitments from nations to reduce their greenhouse gas emissions. Renewable energy sources, such as solar and wind power, have gained significant traction, offering cleaner alternatives to fossil fuels. The development of solar geoengineering is not the work of a single individual, but the culmination of decades of research and innovation by countless scientists and engineers across the globe. However, certain names have risen to prominence in the field, leading the charge in exploring this potentially groundbreaking technology. One such visionary is Dr. David Keith, a renowned physicist and professor of applied physics at Harvard University. Dr. Keith has dedicated his career to understanding the science of climate change and exploring innovative solutions, including solar geoengineering. Another prominent figure in the field is Dr. Jane Long, a physicist and former associate director at Lawrence Livermore National Laboratory. Dr. Long is a leading expert in climate modeling and the potential risks and benefits of solar geoengineering. These scientists, along with many others working tirelessly in the field, are driven by a shared sense of urgency and responsibility to address the climate crisis. They recognize the potential of solar geoengineering as a valuable tool in our fight against global warming, but also emphasize the need for rigorous research, ethical considerations, and global collaboration to ensure its safe and responsible implementation. Their dedication and groundbreaking work are paving the way for a future where humanity can potentially mitigate the worst effects of climate change, creating a more sustainable future for generations to come. Section 5. A Cooler Tomorrow, Envisioning a World with Solar Geoengineering. Imagine a world where the scorching heat waves that have become all too common are a thing of the past. Picture coastal cities no longer under constant threat from rising sea levels, their inhabitants living without the fear of displacement. Envision coral reefs, vibrant and teeming with life, no longer facing the existential threat of bleaching due to warming waters. The successful implementation of solar geoengineering could bring about a significant reduction in global temperatures, effectively turning down the Earth's thermostat. This would have a cascading effect on various aspects of our planet and our lives. The rate of ice melt would slow down, giving vulnerable species like polar bears a chance to adapt and survive. Extreme weather events, such as hurricanes and droughts, could become less frequent and intense, offering respite to communities on the front lines of climate change. Agriculture, a sector highly susceptible to changes in temperature and precipitation, could see increased stability and productivity. The potential benefits of solar geoengineering extend beyond the immediate impacts on the environment. Section 6. Bringing it home. Real-world impacts of solar geoengineering. The potential impacts of solar geoengineering are not merely abstract concepts confined to scientific journals. They have tangible, real-world implications for individuals and communities across the globe. Imagine a farmer in sub-Saharan Africa struggling to grow crops in increasingly arid land. With solar geoengineering mitigating the effects of drought, they could experience improved yields, ensuring food security for their family and community. Picture a coastal village in Bangladesh, constantly battered by cyclones and rising sea levels. With solar geoengineering stabilizing the climate, they could rebuild their lives, free from the constant threat of displacement. Consider the Maldives, a nation of low-lying islands in the Indian Ocean, facing an existential threat from rising sea levels. The successful deployment of solar geoengineering could mean the difference between survival and submergence for this island nation and its people. However, it is crucial to acknowledge that the impacts of solar geoengineering will not be uniform across the globe. This highlights the need for thorough research and modeling to understand the regional variations in impacts and ensure that solar geoengineering is implemented in a way that minimizes potential harm. Section 7. Navigating the challenges. A look at potential obstacles. While solar geoengineering offers a glimmer of hope in the fight against climate change, it is not a silver bullet. This technology comes with its own set of challenges and potential risks that must be carefully considered before any large-scale deployment. One of the primary concerns is the potential for unintended consequences. The Earth's climate system is incredibly complex, and tampering with it, even with the best of intentions, could have unforeseen and potentially detrimental effects. For instance, injecting aerosols into the stratosphere could disrupt regional weather patterns, leading to changes in precipitation that could harm agriculture or exacerbate droughts in certain areas. Another challenge is the issue of governance. Who decides when and how to deploy solar geoengineering? What are the ethical considerations? How do we ensure that this technology is not used for military purposes or to the advantage of certain nations over others? Section 8. A shared responsibility, the path forward. The challenges posed by solar geoengineering are significant, but they are not insurmountable. The key lies in approaching this technology with a sense of shared responsibility and a commitment to international cooperation. We need to invest in robust research to fully understand the potential risks and benefits of solar geoengineering. This research should be transparent and publicly accessible, allowing for informed decision-making. International dialogue and collaboration are crucial. No single nation should have the power to unilaterally decide on the deployment of solar geoengineering. We need to establish clear guidelines and governance mechanisms to ensure equitable and responsible use, taking into account the concerns and perspectives of all nations, particularly those most vulnerable to climate change. Most importantly, we must not allow solar geoengineering to become a distraction from the urgent need to reduce greenhouse gas emissions. This technology should be seen as a potential tool in our arsenal to combat climate change, not a replacement for the hard work of transitioning to a low-carbon economy.